Hey, what's going on? I decided for the sake of thoroughness, and that's because that's how science works, I would try to disprove this again. And so what I did was did the same thing in the fridge again just to see if I can replicate what I did yesterday. But I also did the same thing and did it in the freezer. And since I have a 4-channel data logger, I was able to do both at the same time. And the results are very interesting. So yeah, let's take a look. So in the last couple of videos where I've messed with spreadsheets, I went ahead and manipulated the spreadsheet live while you could watch me do it, just for anyone who's not familiar with manipulating data that you've recorded with a spreadsheet. I figured it could be handy or helpful for someone to see what you could do with it, or maybe kind of pick up on some tricks. But for the sake of making this video short, since it's just kind of a follow-up, I went ahead and already did the data editing. If you want to see that the data is actually here, it is. And obviously, I had to do the freezer first, and then once that was going, then I set the refrigerator side up. So I don't know why. I could have sworn these started at, I think that I could have sworn I started at like 72 degrees, but for some reason in the actual log file it starts off at 68 degrees, so I don't know if maybe I'm remembering incorrectly. Either way, other than that, the data looks fine. It was 72 when I pulled the cans out. Maybe by the time I got the holes drilled and got the data logger like fired up, it had already dropped a couple of degrees. But anyways, that's the only reason why this data starts a little later, is because I got, I went ahead and got the, yeah, actually that's weird too, because I actually plugged those both in nearly at the same time. Anyways, yeah, set the freezer up first, then the fridge side. Obviously the dry ones are the control, so I just put them in the top. I have like a little drawer thing, not a drawer, but like a little shelf thing built into the door of the fridge, and so I emptied that out. I was able to fit the 2 little bowls. I just had a dry one that started at room temperature, and then I had one that started at room temperature that I wrapped with paper towel and then wet it with cool tap water. Now, to make it more fair and to give it the benefit of the doubt, I actually used one single probe from one channel and used that one probe to measure the temperature of both after I drilled the hole to see what the starting temperature was and make sure they were very, very close. One was like half a degree warmer, and for both cases I used the warmer one to be the one that's wet, just to make sure the dry one has a good chance, you know, to make sure we're not giving the one that's wet an unfair advantage. And it still pulled ahead in both cases. But there's a little difference between the freezer side and the fridge side that's really interesting to note. So anyways, this is the data. If anyone wants either of these spreadsheets from this one or the prior video, let me know and I'll just email them to you. Or if you have a good file host you can recommend, I can do that too. But anyways, here's the data. So first we'll look at the freezer, because that's our new data. The blue one is dry, that's our control, and as you can see it's pretty similar. And you know, it kind of waves, and they both wave around the same amount. What I'm assuming that is probably the freezer cycling on and off. And it's, you know, it's sensitive enough to actually pick that up in the readings, which is pretty awesome. It shows you how accurate this thing is. But so in this case, unlike the prior one, you can see that they both start at almost the identical temperature, and very, very quickly the one with the paper towel and the water around it just pulls ahead of it really, really quickly. But if you look carefully, the one that was in the refrigerator, the green and the purple lines, the paper towel trick actually worked more quickly. So I found that to be really, really interesting. So I think what we'll do next is we'll line all these up at, say, we'll find the minimum, the lowest max value for all these. We'll line them up so they all start at the same point, And we'll see if putting it in the freezer is really much quicker than putting it in the refrigerator side. Oh, and I did actually look. It was 30 minutes to get from room temperature to 50 degrees. Yeah, see, it's 12:37, and then I started just before 12, so it's roughly almost half an hour on the dot. And then to hit the same 50 degrees for the control for the freezer side, it was basically an hour, like, on the dot. It's only about a minute off, or less than a minute off. So even in the freezer, wrapping up the paper towel and wetting it with cool tap water is actually still twice as fast. So myth definitely confirmed, and even in the freezer it's the case. And half an hour from 70 degrees seems pretty quick. I don't remember what the numbers were yesterday for when we started it at 75 degrees, but I think it was just around that ballpark. So maybe the freezer is a hair quicker, but we'll find out in a second. We'll line all of these up at the same temperature and then see if the freezer ones pull ahead. And actually, what would be really interesting is to see if the paper towel one in the refrigerator side would be faster than the dry one in the freezer side. So, and I looked at the data from the refrigerator side this time, which is basically identical to what I did yesterday. I just wanted to see if we get the exact same results, make sure it wasn't a fluke, or maybe something was going on. And I even made sure to swap positions this time. Last night I think I had the one with the paper towel ran out on the right side. This time I put it on the left side because I thought maybe there's a vent or there's some kind of a air current going inside the fridge that was affecting one side more than the other. I swapped them this time just to make sure that wasn't the case, and as you can see, the paper towel one still won by a large margin. So I think this is where we should line all the data up and see if the freezer really makes any difference. So it looks like 68.5 is where we should start with all these. So, oh, no. Sorry, I lied. Or, no, yeah, 68.5. 68. And in this case, since we're shifting them, we'll just ignore the time. The time will just be used to see the difference in time, but the actual time when these temperature loggings took place won't correlate with the time in the column A. We'll just use it to be able to tell how long it actually was. So 68.5. Whoops. Tell you what, if you have a mouse with a turbo scroll wheel, it is really handy for stuff like this. Okay, dry. Looks like we started right at 68.5. And then wet. By the way, I'm hitting Control Home to go all the way back up to the top left, and then Control End to go to the very bottom, to the very last row, basically. And if you hold Shift while you do it, then it'll highlight everything in between there. And that's how I'm doing this that quickly, in case you were wondering. And then, let's see. We're gonna have to find a good stopping temperature because not all of them. Man, dry didn't even get to 50, so let's go ahead and just stop it. We'll race them to 50. So I can see this is gonna be really interesting. Okay, 50. Okay. Right at this point, they've all hit 50 except for the dry one in the refrigerator, which just couldn't make it. Okay, first thing we're going to have to do is adjust the axes. Minimum, we'll say 43. Yeah, that's good. Maximum, 72 should do it. No, actually, we'll do 71. Actually, let's do 70. I think that's good. And then major axis, we'll do 2. There, that looks better. Okay, so freezer wet was the quickest. Wow, look at that. See, that I love data like this. Data is awesome. So the purple one is the refrigerator side, wet with a paper towel. The blue one is the freezer side, dry. So if you use the paper towel method and then wet it with water, cool tap water, it'll cool almost identically as quick as if you just put a dry can in the freezer side. That is really, really, really awesome. Now, one thing I didn't get that I should have, I'm not done with this. There's more testing I'd like to do just for fun. In one of the following videos, I'll also let you know the temperatures inside my fridge. We don't ever adjust those. We set those when we moved into the house, and we haven't adjusted them since, so it won't matter when I take the measurement. But I'll go back, get the probe out, and then take a measurement of the freezer side and the refrigerator side, and then we'll have that data to look at. But that is just awesome. So definitely freezer side cools more quickly. So from, what did they start at? Like 68? We'll just say 69. So from 69 degrees, it starts right at midnight. Wow. Midnight is a time. Like I said, we're using this just for difference in time. These don't actually line up with when each of these points up here were actually taken. But so midnight to fail. So we'll just say that's pretty much close enough. So 36 minutes. That's actually 39 minutes. Sorry, this is backwards. So freezer dry and fridge wet. We'll just clump those together, because those started at about midnight and then they hit 50 degrees. Well, they kind of, it's kind of interesting. They kind of go back and forth. It's kind of interesting because actually initially the freezer dry took off a little quicker, and then when they hit about 59 degrees they stuck together until about 55 degrees, where refrigerator wet actually pulled ahead of it. But then right at about 52 or so, the freezer dry side took back off. So maybe at that point, well, actually, I don't know. I wish I would have had time to get these all the way down to, like, you know, nearly freezing. I didn't have enough time to allow the refrigerator side to get that low. I mean, it's 2 in the morning and I work tomorrow, so I really should be in bed right now. But anyways, freezer dry side, we'll go with this right here. So 58 minutes, and that one is, we'll just say 1 hour. They're basically just a couple minutes apart. And then what do we have left? Fridge dry, which didn't actually even make it there, so we can't really count it. Yeah, that's an awesome result. So that shows you if you're at work where you have a freezer but not, or a refrigerator but not a freezer, by wrapping your can of beer or soda, well, probably not beer if you're at work, but wrapping your can of soda with a single sheet of paper towel and then wetting it with cool tap water will cool it down almost identically to if you had a freezer and you just put the can straight in there. So that's awesome. I love data like this. So hopefully you guys found that interesting. I'm definitely going to do more testing on this just to see, well, just to try to narrow down what could potentially be causing the wet one to cool more quickly. Because obviously with that tiny amount of water that's soaked into the paper towel, it's not like it's there's a temperature differential. You have cool tap water that's probably 50 degrees or something, and then you have the 75 some degree soda. So obviously until those equalize, that's going to cause cooling by itself. But then once they hit the same temperature, I'm curious if at that point that's what I'll do to test that, to find out if that is causing the majority of the cooling lead, because it starts pulling ahead really quickly. Is that what's causing? It's the temperature equalizing and the water, the cool water soaking the heat out of the can until they neutralize and kind of hit the same temperature. Equalize would be better than neutralize, I guess, until they equalize, and then maybe evaporation at that point helps make it take off more. I think the way I'll test this is to get a probe, measure the temperature of the inside of the soda can, and then adjust my faucet until I get water coming out at the exact same temperature. Wet the can with the identical temperature as the liquid inside, water, then put it in the fridge. And then compare it against one where I have my faucet set to its coolest setting, measure the temperature of that just so I know what I'm working with, and then also have a control dry can in there. And then we'll see if the one with the cool tap water has any big advantage over the one that has the tap water set to the identical temperature inside the can. Because if we set it to the identical temperature inside the can and it still gets ahead, then we'll know that it's got to be evaporation helping it, or maybe it's the liquid helping, the kind of liquid to air cooling effect versus just air against the metal, which would just be regular air cooling. I don't know. It'll be interesting to try, so that's probably what I'll do tomorrow if I have time. Tomorrow is my Friday for the week, and I'll have a 4-day weekend, so hopefully I'll do a lot more testing on this and make some short videos like this. But yeah, see you in the next video, hopefully tomorrow. Bye.